I think this first step here, deciding if it's a perfect square or perfect cube, I'm hoping we're okay with that. Let's make some space here. If you want to decide if this is a perfect square, as I said before, you need to look at its prime factors. 324, when you factor it all the way down, I mean, you can sit here and try dividing it by 2, and you get all the way down here. I'm just going to write down what the factors are now, however you end up with the factors. The factors for this thing you end up are 2 times 2 times 3 times 3 times 3 times 3. Those are the factors you end up with. Okay? If you're deciding if it's a perfect square, you can decide it based on, can I make 2 groups out of it? Or do they occur in pairs? Because that means I can make 2 groups out of it. So if you want, you can say, well, they're all in pairs. Look, they're pairs, right? I can make pairs out of them. Or in other words, if I tried to divide them into 2 equal groups, which I can do, right? Because I can take 1, 2 and put it over here. 1, 2 and put it over here. Take a couple of the 3s and put it with this one. Take a couple 3s and put it with this one. So I got my 2 equal groups, right? I should probably, if I was going to try, if you're, writing a test and you're trying to show me you know something about it, don't just put this. Because I know a lot of you just factor it and then you write this down. The most important part is the explanation, right? You should put something like, you can make 2 equal groups out of the factors, right? You can make 2 equal groups out of the factors. From the prime factors. Oops, missed one. You can show me, I don't even care how much the factoring steps you show me, but this is what you need to show me, right? And then, how could I figure out what the square root of this? If I asked you what the square root of that is, how can you tell what the square root is? If I made my 2 equal groups, how would I figure out what the square root is? Well, if this times itself gives you 324, isn't each of these the square root? One of those groups, if you multiply it out, you get 18. You get 18 there. The square root is one of those groups. All right? Let's look at the other one here, 432, if you want to know if it's a perfect cube or not. If you try to factor this down, again, I'm not going to write down, sort of make a factor tree here or whatever, but you end up with 2 times 2 times 2 times 2 times 3 times 3 times 3. And you're trying to decide, is it a perfect cube? You can decide if it's a perfect cube by deciding whether you can make 3 equal groups. Can you make 3 equal groups out of that? You can't, right? Because you could take a 2 and a 3 and a 2 and a 3 and a 2 and a 3. But there's an extra 2, right? And then where does this extra 2 go? So you should probably say something that shows that you know, right? Cannot make 3 equal groups, therefore not a perfect cube. 3 equal groups, not a perfect cube. All right? Good. I think this is something you guys can get, right? You can get that, and that's a big part of that first section, right? Number 3 and 4 on here. Number 3 and 4, this is changing from mixed to entire radicals and back and forth like that. This thing, root of 160, if you're trying to make that into a mixed radical, again, there's the 2 different approaches. I think probably for some of you, you're having more success doing don't break it down all the way, just break it down. Look for perfect square factors. If you know your perfect square factors, 4, 9, 16, 25, 36, and so on, look to see if you can divide it by those numbers. Can I break 160 down into 2 factors where one of them is a perfect square? How can I break down 160 into just two factors, where one of them is a perfect square? 16 and 10. 16 and 10 is probably the quickest way to do this one, but it's not the only way. If you see that you can divide it by 16, divide it by 16 because you can make two separate square roots then. Root 16 times root 10, and do you know what square root of 16 is? You do, right? Break it down into two factors where one of them you know the square root. Square root of 16, you know, what is it? 4. So it's 4 root 10. Look at the number that's left over. Whoops, don't scribble on the number that's left over. Look at the number that's left over and see if you can divide it again by a number that's a perfect square. You can't break down 10 anymore. The only things are 2 and 5, and neither of those are perfect squares, so you're done. Let's say you didn't recognize that you could divide it by 160. Okay, let's say you didn't, so let's do it one other way here. Let's say you didn't recognize you could divide it by 160, and let's say you just made it 4 times 40. 4 times 40. 4 is a perfect square, right? Try and divide it by perfect squares. Don't necessarily just try and divide it by 2 and 3 and stuff like that. Try and divide it by perfect squares and break it down. Square root of 4, you know, so you can put a 2 out in front and you're left with the 40 inside. Can you break down 40 into another perfect square? 4 times 10. Put the other one out there then. So put a 2 outside for that 4. A 4 inside the square root sign is like a 2 outside the square root sign. Okay? And then so once you've got it to that point, you got 2 times root 10. So it's 4 root 10. Okay? This one over here is cube roots, but it's the easier way. It's the way of putting the numbers in, not taking them out. 2 times cube root of 5. You need to change this 2 into the cube root of something. In other words, you have to cube the thing. Times it by itself 3 times. What is that the cube root of? If you cube that number, what do you get? 2 is the same as cube root of 8. So you got cube root of 8 times cube root of 5. That is the same as the cube root of 8 times 5. Or in other words, the cube root of 40. Okay, that's the same as cube root of 40. These two here, a lot of you I know got to question 5 and you're okay, and then question 6 was where it started to cause problems for you, but we'll deal with that in a second. This one, 4th root of x to the 7th. Some of you just memorize, or have just memorized that this number is the top of the fraction and this number is the bottom of the fraction. That's okay if you've done that. If you haven't memorized it, you can actually just do it from an understanding kind of point of view here. That thing that's in yellow, if you have the cube root of that thing that's in yellow, what's that the same as a power? How can you write that as a power? 4th root of something is the same as something to the power of, it's a fraction, 1/4. Okay, we need to know that. 4th root is the same as to the power of 1/4. Once you do that, then you can use your grade 9 rule, which says, what do I do with these two exponents if I have a power of a power? What do I do with them? Power of a power, what do you do? What do? You multiply them. 7 times 1/4, x to the 7 quarters. Okay, that's what it is. You can memorize it and just jump straight to there if you want. For some reason, this negative exponent thing is troubling us more than it should. 2 to the negative 4th, negative exponents are reciprocals. Okay? Reciprocals, meaning you just flip it over. 2 to the negative 4th is the same as 1 over 2 to the positive 4. Or you could think about it like this. Some of you would prefer to write this number as a fraction. If it helps, write the base as a fraction all the time if you want. You could, instead of writing it as 2 to the negative 4th, you could say 2 over 1 to the negative 4th, because then what can you do with that 2 over 1 to the negative 4th? You can flip it and make it 1 over 2 to the positive 4th. 1 over 2 to the positive 4th. If you do a half to the power of 4, if you go a half times a half times a half times a half, what do I get? a half to the power of 4. Take a half, multiply a half a whole bunch of times, you get 1/16th, right? You get 1/16th this way as well, right? Because you just say 2 to the negative 4, it's like 1 over 2 to the positive 4. 2 to the 4th, you know what that is. It's 16. You should know your powers of 2. You know how I'm saying up here you should know your perfect squares up here somewhere? I made a list of perfect squares. You should know your perfect squares. You should know your powers of 2. It isn't even that hard to generate them if you need them. What are powers of 2? So that you can right away say 2 to the 4th is 16 without a lot of trouble, right? What are powers of 2? Make a list of them here. 1, 2, 4, 8, 16, 32. What's the next one? 64, 128. It would be helpful if you recognize some of those numbers. Not necessarily that you say, oh, 1024, I know that that's 2 to the 10th. I don't mean that, okay? I mean 1024, well, maybe not that one, but if you see 64, you should say, 64, boy, I've never seen that number before in my life. You should probably say 64. It has something to do, I know, you can't fool me. It has something to do with powers of 2. Let me see. It's 2 to the something. Like, you should recognize that it's a power of 2. Okay? It would be helpful. Okay? You've seen it enough times. I think you should recognize that it's involved. Here's where the trouble starts, I know, for some of us. Here's where the trouble starts. Probably some of us, if not all of us, should watch this. Okay? I think some of you say, let me say up front here. Let's see what it has involved. It has exponents. You probably don't like those, or you think you don't like those. It has fractions. You probably think you don't like those. It has negatives. It has it has a lot of things. It has brackets. It has a lot of things that probably you have thought that you don't like in the past. It not only has all three of those things, it has exponents that are negative fractions, right? That's why you look at it and say you think it's hard. I am going to write about 6 steps before I get to the answer. Don't try to jump right to the answer. Do a few steps. Deal with one thing at a time. You have to think to yourself, if I have something to a negative exponent, right? So if I have yellow box to negative blue here, how can I rewrite that? 1 over whatever that yellow box is, right? You can do the reciprocal. Or if the yellow box is written as A over B to the power of that blue box there, how can I rewrite it without the negative? B over A, right? B over A to the positive, whatever that little blue box is, right? So I can change this. My first step here is going to be to write this as 9 over 4 to the power of 3/2. Well, as I was going around helping you guys with this question, a lot of you, once we talked about flipping it over, your first instinct wasn't to flip this over. What was your first instinct? To flip this exponent over? Just because the exponent is a fraction, don't think you need to flip that over, right? It's the base. You flip the base over. So there you've dealt with the negative exponent, and then we're going to deal with this fractional exponent. First deal with the negative exponent, then deal with the fractional exponent. I think it's easiest if you split up this fractional exponent. Any fractional exponent, I think you should split it apart. So you should write it as, instead of 3/2, write it as 1/2 times 3, or 3 times 1/2. 3/2 is like 3 times 1/2. That's what it means, right? That's why you call it 3/2. 3 times 1/2. The reason that helps is because you can do the two things separately. What does the power of 1/2 represent? What's that the same as? Power of 1/2 is the same as, and this is the key, if you can get this, it's the same as a square root. Power of 1/2 is the same as a square root. Let's scroll back for a second here. 4th root was the same as the power of 1/4. Half is the same as, power of 1/2 is the same as the square root. So you can write that as square root of 9/4 to the power of 3. If you still would like to have the brackets there, you can have them. But now that you have a square root over it, you don't really need it. But it's up to you. Okay? If you want to take them out of there, you can. You could put brackets there if you want to say that it's to the power of 3, but you don't need those either. Some of you didn't like doing square root of a fraction. Let me tell you that you have to think carefully about the numbers you're using here when you're making up these questions. I wouldn't have done this if this was a square root of 7/5 to the third, because can you work out the square root of 7 in your head without a calculator? No, right? It's not going to be that. Can you work out the square root of 9 and the square root of 4? Because let me tell you something. This is just those separate square roots. Not that you have to write that, but you can just write and say, if I want to know the square root of 9 over 4, what is it? Square root of 9 over 4 is 3 and a 2. If it makes you cry to have that step in there because it looks more complicated, don't put it in there, okay? Just say square root of 9 quarters is square root of 9 over square root of 4, 3 over 2. Okay? I know that long questions make you cry just in themselves without that step in there, but now we've got it down to where it's hopefully almost a grade 9 question, right? 3/2 to the third. If it makes you happy to make these two separate steps, you can say it's 3 to the third and 2 to the third. Okay? Each of those numbers to the third. If there's brackets there, it's both of those to the third. If you want to just skip that step and go straight to, I know I have to raise each of those to the third. What's 3 to the third? 3 times 3 times 3? 27. 2 to the third? What's 2 to the third? This is what it is. That's the answer to that question. Okay? That's a lot of steps. Look back how many steps there are. You don't have to do all the steps in that order, but I think that's probably the easiest way to do it. Want to go back down here for a second? This again also looks kind of ugly to work with, but just do one thing at a time. A few of you asked this question. You said, does this 2 in here apply to both of these things? Or just the x? What's the answer to that? Just the x, because if we wanted it to apply to both of those, we'd have to put another set of brackets in there. If there's a power there, it's just on the first thing. You can do a couple different things here. I would deal with, well, one way to deal with this would be to, if you want to deal with a fractional exponent and turn it into a square root, you can. The fact that that's a 1/2, you can look at this and say 4 is a perfect square, x squared is a perfect square. I could actually get rid of the fractional exponent right off the bat if you want to. But you don't have to. Okay? You can, the fact that this says this whole thing to the 3/2, you can deal with that first. So I'm going to write it on the top as 4 to the power of 3/2 times x squared to the power of 3/2. 4 to the power of 3/2, x squared to the power of 3/2. If you have 3/2, I would write it as 4 to the 1/2 to the 3. And you can write this as x squared to the 1/2 to the 3. It looks like I'm making it more, actually that one's easier just to get rid of right away, but yeah, that one's easier to get rid of right away. 2 times 3/2 here, what does this give me? What does this give me? 2 times 3/2, what's that? 6/2, right? 6/2 is the same as what? 3, okay? That's the same as 3. Inside here, well, how can I write this 4 to the power of 1/2? That's like square root of 4. How can I write that? 4 to the 1/2 is like square root of 4. What's square root of 4? Again, we don't want the internet people to think you're not that bright, right? You know this, right? 4 to the 1/2, square root of 4. You know what it is? 2, yes. There, just to note, they're all saying 2. They all know that that's 2. Look, there's people around the world watching this. Not many, but some. Now, I have done something that's very bad mathematically now that we talk about people around the world watching. What did I forget to do here? I forgot to keep track of the bottom, right? This is a really ugly question. What kind of idiot would make this up? You. 3 to the power of negative 2 times x to the power of negative 2 times x to the power of negative 4. That's really ugly, isn't it? How can I write that a little more simply? Three to the power of negative 2, x to the power of negative 2, x to the power of negative 4. All I did there was said it's both of these things to the power of negative 2, so I just wrote them each with the power of negative 2. If you do one step at a time, it's not that bad. If you just look at it and say, oh my goodness, look at this. It's such a mess. I'm never going to be able to deal with it. And you just sit there saying that for a long time. How can I simplify this on the bottom now? I got two different powers of x. I could put them together. What could I write them as? I'm going to leave the 3 to the negative 2 alone for a second, but I want to try and do something with this. What could I do with those two? If that was sitting there all by itself, you would get it right. I know you would. But once it's within another bunch of stuff, you freak out about it. If that part that was in green was by itself, you'd get it right. What is it? Two powers you're multiplying? You add the exponent. So what do we got here? X to the negative 6. Okay? Now, we've simplified the top down to this, right? The top was all the way down to that. 2 to the third times x to the third, right? The bottom here, let's think about what we're going to do with this. We have 3 to the negative 2, and we have x to the negative 6. If you have a big complicated fraction like this, and you have negative powers on the bottom, the simplest thing to do is to just put them on the top. But what can you do with them when you put them on the top? If you take this 3 to the negative 2, and you take it from the bottom and you put it on the top, what can I do with it if I put it on the top? Change it to a positive exponent. The same with this x to the negative 6 here. If I take that x to the negative 6 and put it on the top, it's like a positive. The first thing we did when we talked about negative exponents is we said multiplying by a positive exponent is like dividing by a negative. Or dividing by a negative power is like multiplying by a positive power. So if you have it on the bottom and it's negative, we can just put them on the top and make them positive. Alright, so we got that. What do we have left on the bottom? Nothing. It's like a 1. You don't even need it there anymore. Okay? So that's like it's not even there. We have a whole bunch of stuff there we can work out. You can work out each of those things easily. I'm pretty sure. This is 2 to the third is, remember, internet people watching, remember, 2 to the third is 8. 3, I'll give you a chance to redeem yourself. 3 to the second power is 9. All right, I like how quick you answered that. X to the 6th. So now we got a bunch of things here. Some of them are numbers. Some of them are also numbers, but we don't know what those numbers are. They're powers, right? So we got 8 times we got a bunch of stuff, and it doesn't matter what order you multiply it in. So I would like to multiply the 8 and the 9 to get 72. Remember, internet people watching. And we have x to the power of 9. All right. That is the answer. Okay, that is a very ugly question. Okay? Well, okay, if we're talking about the test, no, because no, listen, look back here. No, I said no, right, when you said that, right? Yeah, I did. I said no. Okay, let's look back, because it's not, I probably the term warm up is not good, right? Because a warm up that makes you not feel good about what you're doing is not really a warm up. It is depressing. This is like when I go out with one of the hockey teams I play with. I'm a goalie, right? And they warm me up by, see, they're not necessarily good shots, right? So they're all lined up shooting, and it's like by my head down here and stuff. you're not supposed to freak me out here with this, right? You're supposed to warm you up by giving you stuff you can do. So I apologize that the warm-up had those questions at the end. I want you to realize that for the test is not all stuff that looks like this. If I put a question like this on the test, can you listen? If I put a question like that on the test, that's not distinguishing between the person that was not here for class most of the time. And that's not distinguishing between the person who's passing and failing. That's distinguishing between the person who gets 90% and the person who gets 100%. So unless your goal is 100%, don't worry about that question, right? Don't worry about that one. I think you have to have reasonable goals about things, right? There might be one question like that, but it's not going to be all questions like that. However, if I ask you this is distinguishing between the person that either wasn't here or really didn't do a whole lot in this unit. Okay? You should be able to do that. You should be able to do this because really, I have news for you. You learned it in grade 8 as well, right? Is that a perfect square? Break it down 2 equal groups. I'm not telling you that to make you feel bad if you couldn't get that one before. I'm telling you that because it's not as hard as you think. Don't think the whole unit is hard just because there's this hard question, right? And maybe this one's a bit hard too. Focus on what you can do, not what you can't do. This is a very long video.